Hey guys, it's Mr. Gibson here. I'll show you guys some key features of graphs of exponential functions. The first thing is to illustrate when an exponential function is in decay or growth. Decay means that y values are decreasing as x values increase. So the way that the graph would look is this. It starts from a high point and it goes slowly into a lower value. Okay? So as the x values go this way, the y values decrease. In the opposite way, growth is when y values increase as x values increase. In this case, we'll start small, y values that are small, and go up very quickly like this. Okay? So they're both inverted of each other. They're both flipped from each other. So the decay looks like this, and flipped over looks like growth. Okay? That's the first thing to notice, and we'll revisit this idea throughout the video. Next thing is the y-intercept. Okay? It's just like the y-intercepts that we have seen throughout this class. It's only where the graph touches or goes through or crosses the y-axis. So in this case right here, we've got this graph going through the y-axis at y equals 3. So that means that we have a y-intercept of 0, 3. Okay? X value is 0, y value is 3. Like our other graphs that we've talked about earlier this year, we have an average rate of change. And how this works is this way. We're gonna, an example, well, you guys have this formula right here, if you guys remember. I won't go through it because you guys have seen it in earlier videos. But in an example here, we're given an interval from 1 to 3, okay? It can be written in this interval notation, or it can be written like this, okay? So all I'm gonna do first is just label my points at x equals 1 and x equals 3 on this graph. So right here, got a point right there, 1, 2. Okay? And for the y values, or not for the y values, for the second one, for where x is equal to 3, go over here, go up, where x equals 3, y equals 8. Okay? So I'm just going to simply plug these points and values into the formula right here. So y2 is 8, so I'm going to plug in 8, minus y1, which is 2 from the first point. Okay. Then I'm going to do my x's, so I'm going to start with x2, the second point, which is 3. Okay. Minus x2, which is 1. Okay. From there, I'm just going to simply simplify. So that means it equals 8 minus 2, which is 6. 3 minus 1, which is 2. So that gives me 6 halves. And then 6 divided by 2, or 6 halves, equals 3. So the average rate of change between those 2 points is 3. Okay? So that's just a review of what we do with average rate of change. The next is what we talked about with other functions as well, are intervals of increase and decrease. Okay? And the good thing with exponentials is if you can identify growth or to identify decay, you can identify the intervals of increase or decrease. So in this example right here, this orange curve, we're experiencing growth. So that means that this function always increases. So a growth function will always increase. Okay? And it starts increasing all the way where x is negative infinity. And it increases all the way to infinity. Okay? Another way to write that is when x is greater than negative infinity and x is less than infinity. Okay? Another way to say that is it's increasing at all real numbers. Okay? Similarly, but the opposite is decay. A graph that's decay is always decreasing. So we just said the interval of decrease is all real numbers, or in this case from negative infinity to positive infinity. Okay, that's an interval notation, or from x is greater than negative infinity to x is less than infinity. Again, that just means all real numbers. Okay. The last thing is something called end behavior, and we have not studied this yet. Okay, so this is your first introduction to it. In future math classes, you'll do a lot more work with this, but right now we're going to do the most basic with these exponential functions, and hopefully it'll help you guys understand what it is as you guys move forward. What I like to call, how I like to define end behavior is where the graph ends up as it goes to the left and as it goes to the right. So rather than looking at intervals of increase or decrease, we simply say, okay, as the graph goes right, does it go up or does it go down? As the graph goes left, does it go up or down? Okay, and often you're going to have to use these little infinity or negative infinity symbols here. Okay, very similar to our intervals of increase or decrease. Okay, so keep this this little chart in mind. So let me show you guys. Again, we're just going to have two examples here of when there's growth versus when there's decay. Okay, so here's our growth, this orange one. So we say as x, this little arrow means approaches infinity. Guys, all that means is it as when x goes right. Okay, so as x goes right, okay, as we're going right on this, f of x, which just means the graph, where's the graph going? Well, if I look, the graph is going up, and it just keeps going up. So I'm just going to write up, and the way to express up is just the infinity sign. Okay, so the next one has x approaches negative infinity, which again, y'all, simply just means as we go to the left. So if you guys look at this, as we go to the left, it doesn't just keep going down towards negative infinity, it kind of just levels out forever. Okay, so it actually levels out or approaches the x-axis, which actually is y equals 0. So we're going to say it approaches 0. Okay, so as it goes to the right, it goes up forever, so it goes towards infinity. As it goes to the left, it just keeps getting closer and closer and closer to 0, but never quite touching it, so we say it approaches 0. Okay. Again, with decay, kind of similar but inverted. Okay. As x goes towards infinity, or as x goes to the right, as the graph goes to the right, what does the graph do? Well, as it goes to the right, it doesn't go down forever. Okay. It simply gets closer and closer to this x-axis, and so we're going to say it approaches 0, because that's where y equals 0 is the x-axis. Similarly, as x approaches negative infinity, that means as the graph is going towards the left, where does the graph go? Does it go up or down? Well, it goes up, and it just keeps going up forever, so we just say it goes towards positive infinity. Thanks you guys for your attention.